Welcome to the video series for making a vise stop. And what a vise stop is used for is to put on your jaws so that your part has something to butt up against. So let's say you have multiple parts with a certain hole in it, then you can butt those parts up against your vise stop. Now you can go on Amazon and buy these, but we are going to make these start to finish so you guys understand the process of how to actually mill one. So the tools that you're going to need for this series is going to be a rougher finisher. It doesn't really matter what size, but I'm going to use a 1/2 inch rougher finisher. You are going to need a drill and tap for a 5mm tap. You are going to need a drill mill, and you are going to need a block of steel. I would recommend 4140 pre-hard. I wouldn't make this out of aluminum, but you could also make it out of something that can be heat treated, and you can heat treat it after you tap it and after you finish the whole block. So pretty much anything you're going to need to deburr it, so a file or a stone. And other than that, that is all the tools that you're going to need. In the next video, I'm going to explain the processes we're going to take and show you guys verbally how we're going to mill this, and then we're going to go in from step 1, 2, 3, and 4 and make a video for each one of those. And we're going to compile all these videos and create this series so you guys will know from start to finish how to make this stop. Guys, hopefully at this time you already have your print, and if you notice, we have made some modifications. This is a block that was made about a year ago, so we have taken one of these reamed holes out to make it a little easier. You really only need one, and what that's for is so you could stick a bar of material in there and butt your part up against that bar of material. Now that's not, you don't have to have that, you can butt it up against the stop, but in this video we're going to be talking about processing this part, how we're going to go about making it. Now there are 1,000 different ways you can go about making this part. How we are personally going to do it is we're going to put the block of material in the vise sticking up high enough so that we can profile it like a CNC mill, skim the top, and then we're going to flip it over, deck it down, leaving this slot out, so that we can, it'll make it easier to add all these holes in. So then we're going to add in the reamed hole, the tapped holes, and then the very last, what we'll do is we're going to stand it up and mill this slot out. Then after that, maybe the last thing we're going to do is actually drill mill it. So we'll make sure that we're deburred throughout this entire process, staying clean. And right at the end, after we mill this slot out, what we're going to do is put up a drill mill, and any sharp edges we're going to knock off just to make it look good, and drill mills do an amazing job. And if you don't know what a drill mill is, you can look it up online. All it is it looks just like an end mill, except it has a 45-degree angle here and here, and it's good for adding chamfers on your parts. Okay, now other ways you can go about doing this if you want to is you can have this part in your vise sticking up high enough, and you can profile it with your end mill and add this slot in and this step right here. And you can do that all at once, flip it over, put it on a set of gauge blocks so that you're not sitting there unevenly, and then decking it. Now, like I said before, the reason that we're not going to do that, and we're going to do that last, is so that we can add in all these holes and not have to worry about adding gauge blocks and things like that. So in our next video, we are actually going to be profiling this part, and then after that we will be decking it. So let's go ahead and get started. So the very first thing we're going to do is profile this part. Now I have sawed this part to where it's only about 100 thou on each side, and I have skimmed, I don't know if you can see that, but this is a sawed edge up against my front jaw, and I put it on the factory edge on the back and skimmed it to where whenever you're clamping this part, you're not holding on to any sawed edges, because it can twist and pop out once you're profiling it. Okay, so the first thing I'm going to do is skim this top. Then I'm going to drop my end mill down 750 thou, because that is the thickness of my part. You can go a hair deeper. And then I'm going to profile it. So very first thing is I'm going to turn my spindle on. I'm going to touch the top and skim it. You can skim it with a shell mill. You can also use oil. Alright, now that I've skimmed the top, what I'm going to do is turn my spindle off, and I'm going to zero out my knee. So I'm going to loosen the lock and zero it out. And then I'm going to go down 750 thou. So $750. All right, and I've also scaled this part out, and I have my scale here to make sure that it's not going to hit my vice jaws. So that's 800 thou, 800, which I've already scaled before I actually skim the top. All right, I'm going to move my end mill to the back, and what I want to do is I want to get two squared up faces. So I'm going to go along the back of the part and skim it, and then I'm going to skim the right side of the part. And when I do that, I'm actually going to set 0 on my DRO so I know exactly where those edges are. So I'm going to turn my spindle on. And it didn't clean up, so I'm going to move it again. And I'm going to do something called the spring pass, which means that after you cut, your end mill can actually push off of your part. And what you want to do is something called the spring pass. Just go back and forth so it's going to cut extra material. Okay, from there I zeroed out my DRO. I'm going to move half my end mill. Now you can leave it set on the edge of the end mill as 0, but let me go ahead and zero this out real quick. But just in case if I forget something, I know I'm exactly, my 0, 0 is the exact center of this back right edge now. That we have finished getting our back right 0, 0, I have moved the end mill plus half of the diameter of my end mill, and now we are ready to take this full cut. Now, where the end mill sets now in X, that is my finished dimension. What I'm going to do is actually back off of that and side mill up to that finished dimension so I don't chip my end mill or anything. Just taking a full cut. You can take a full cut depending on which material and what kind of end mill you're using, but for what I'm doing and what I'm showing you guys and the material I'm using, I'm just going to side mill. So I'm going to turn my spindle on, and we're just going to side mill all the way up to my 0. Okay, so now I only have 11 thou left. So I'm going to take half and half. Now this is the point where I can either get a finisher if I have a part that doesn't need any taper in it and it needs to be perfect. But for what we're doing, I'm just going to use our rougher to finish it. So now I'm at 0. Now I'm going to take my spring passes to make sure I get all the taper out. Alright, and now we're moving on to now the Y dimension. Our X dimension should be set. So now our other dimension that we're looking to go to is 1.25. Then we have to add half of our end mill, so it's going to be 1.5. So we're going to go to 1.5 and set our 0. Okay, so be sure when you're roughing the conventional cut, because when you climb cut roughing on a manual machine, it can actually pull and drag the table just a little bit, and you'll feel it. It's a lot easier to actually to rough with conventional cutting. All right, so I'm just going to leave, like I said, about 10 thou for a finish pass. The main place you're going to be messing up is forgetting half of your end mill or the entire diameter of your end mill. Other than that, that is how you profile the part. And all we have to do now is take it out, deburr it, flip it over, deck it. And before we take it out, we want to check our sizes to see if we need to actually skim anything else. Other than that, that is how you profile a part. And be sure when you're roughing, you're actually conventional cutting, because it is a lot more rigid than climb cutting on a manual machine. When you're on a CNC, climb cutting is perfectly fine. But like I said before, conventional is where it's at when it comes to roughing.